Hello and welcome to revision classes on television. Today, we will be having a session in mathematics. Our guide is Abiodun Idowu and our topic today is circle geometry.
The first theorem we are going to look at today is that the angle which an arc of a circle subtends at the center is twice the one it subtends at any point on the circumference. This theorem is important because it's one of the theorems specified for you to learn. So let me put this theorem on the board and show a diagram to illustrate this particular theorem. Theorem 1 states that the angle which an arc of a circle subtends at the center is twice the one it subtends at any point on the circumference. Now, this theorem can be illustrated in a circle. When we have a circle as shown on the board, this is the center of the circle. We can have an arc AB. This is the arc AB. It is the minor arc AB. Now this arc AB puts an angle at the center of the circle. The same arc AB puts another angle at the circumference here. What this theorem is telling us is that if this angle at the circumference is x, the one at the center will be 2 times of x, because the theorem says the angle which an arc of a circle subtends at the center is twice the one it subtends at any point on the circumference. Take note of the fact that it could be any point, not necessarily here. I can have it here, I can have it here, I can have it here. So this is the diagram to illustrate this particular theorem. The theorem once again says the angle which an arc of a circle subtends at the center is twice the one it subtends on any point on the circumference. Put this down in your notes. We are also going to move on to another theorem. Let me call that Theorem 2. Theorem 2 is talking about semicircle. What is a semicircle? A semicircle is when you divide a circle into 2 equal parts. Each part is a semicircle. What you are going to use to divide a circle into 2 equal parts is the diameter. The diameter of a circle is a line that passes through the center of the circle and is joining 2 points on the circumference. So this particular theorem is about a semicircle. And the theorem states that the angle in a semicircle is right angle. What is a right angle? A right angle is angle 90 degrees. So in essence, the theorem is telling us that angle in a semicircle is 90 degrees. Let me show an illustration to depict this particular theorem 2 on the board. Let me write the theorem. Angle in a semicircle is a right angle. If this is the center of the circle here, and this is the diameter dividing the circle into two equal parts, then what we are saying is that this angle, if this is A, this is B, and this is C, this particular angle ABC is going to be 90 degrees. That implies angle ABC is 90 degrees. That is what this particular theorem is talking about. Watch out for the diameter of a circle. It will guide you to know if we have an angle in a semicircle, because it is the diameter that is projecting this angle on the circumference. Any angle projected on the circumference by the diameter is going to be 90 degrees. Take note of this theorem number 2. Theorem 3 says that angles in the same segment are equal. Let me put the theorem on the board and illustrate with a diagram. Angles in the same segment of a circle are equal. If I have a circle like this, and I have lines of these forms, if I call this A, B, C, D, and E, what this theorem is telling us is that if you look at all these angles, the three angles shown, they are all in the same segment. How will you know maybe they are in the same segment? They are all put in place by the arc AB. If you look properly, this arc AB puts this angle on the circumference. The same arc AB put this particular one too on the circumference. The same arc put this one on the circumference. Therefore, these three angles are going to have the same value. If this is X, this will also be X, and this will be X. The three of them are angles in the same segment of this particular circle. So in that case, I can write angle ACB is the same thing as angle ADB, and it's also the same thing as angle AEB, all equal to X. So theorem 4 is talking about cyclic quadrilateral. It says opposite angles of a cyclic quadrilateral are supplementary. What do we mean by the angles being supplementary? It implies that when you add the two angles together, you get 180 degrees. Let me write this theorem on the board and illustrate with a diagram. Opposite angles of a cyclic quadrilateral are supplementary. Being supplementary means add up to 180. Now, before I'll go into details, what is a cyclic quadrilateral? A cyclic quadrilateral is a quadrilateral that is inscribed in a circle such that all the vertices are on the circumference. If it is not a cyclic quadrilateral, this theorem will not work for it. So you have to ensure that you are dealing with a cyclic quadrilateral before you can apply this theorem. Let me draw a cyclic quadrilateral on the board. If I have a cyclic quadrilateral like this, A, B, C, and D. A quadrilateral is a plane shape having 4 straight sides. If you look at this plane shape, it is inscribed in the cycle such that all the vertices are on the circumference. So this is a cyclic quadrilateral. Now, if this angle here is X, and the one here is Y, and the one here is P, while this is K, what this theorem is telling us is that if I add this angle and this together, I'll have 180. That is angle ADC plus, that is ADC, this angle, plus angle ABC is going to be 180. In a shorter version, this is X plus Y is going to be 180. The same thing is applicable for these two opposite angles. So I can say angle BAD plus angle BCD will also be 180 degrees. In a shorter version, this can be P plus K is going to be 180 degrees. All these theorems are very important because those are the things that will guide you to answer questions involving circle geometry. I move on to theorem number 5. The theorem states that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. When we say exterior, it shows that the angle is outside the quadrilateral. So let me write the theorem and illustrate with a diagram. Exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Let me illustrate this with a diagram. If I have a cyclic quadrilateral like this, one I'm drawing on the board, this is a cyclic quadrilateral. If this is A, this is B, C, and D. This angle here I can tag it as angle Y, is going to be the same as this particular angle here. That is angle ADC. That is what the theorem is saying. That's angle CB. Let me tag this place point E. That implies that angle CBE, which is Y, is going to be the same as angle ADC. Exterior angle of a cyclic collateral is going to be equal to the opposite interior angle. So what are we saying? Angle CBE, which is this CBE, is going to be the same as ADC. That is what the theorem is telling us. It is only applicable to cyclic quadrilateral. So we move on to theorem number 6. The theorem says that tangent is perpendicular to the radius at the point of contact. So theorem 6, tangent is perpendicular to the radius at the point of contact. What are we saying? If two lines are perpendicular, it implies that the angle between the two of them is going to add up to be 90 degrees. Let me illustrate this particular theorem with a diagram. If I have a circle as shown on the board, and there is a tangent. A tangent is a line that is just making a contact with the circumference of the circle. If this point of contact is T, this is A and this is B. If this is the center of the circle, O, if I draw a line from the center of the circle to point T, where the tangent make a contact with the circle, then the angle between them is going to be 90. That is what the theorem is telling us. It is not going to exactly be like this alone. I can have another tangent here. Let's say this is another tangent. And this is also a radius. At the point of contact, this angle here will also be 90 degrees. That is what the sixth theorem is telling us. We move on to another theorem now. The next theorem is also going to talk about tangent. This time around we are talking about tangent from an external point. We are talking about two tangents, so say tangent from external point are equal in length. Let me draw a diagram to illustrate this theorem. If I have a circle like this, and this is the center of my circle, and I have the center be here, I have a line from the center to an external point as shown. Then this is a tangent to the external point. This is another tangent to the external point. from this point of contact to the center of the circle, we have a radius. There is the center 0 or O. We also have a radius here. We have said initially that at the point of contact to the radius, the angle will be 90. So this angle here will be 90. If I join this to this, what this theorem is telling us is that this length is going to be the same as this length. I'm talking about length CB is going to be the same thing as length AB. Both of them are tangent from an external point. So CB is going to have the same length as AB. Likewise, this angle here is going to have the same value as this particular angle here. The same thing is applicable here. The angle here will also be the same as the angle here. But we focus on the fact that tangent from an external point are equal in length. This symbol shows that these lengths are equal. That is why we have the same symbol there. Now we go on to theorem number 8. And theorem number 8 says that angles in alternate segments are equal. Angles in alternate segment are equal. Now let's put this in a diagram. If you have a circle like this, and there is a tangent, which is ABC, and then we have a triangle inclined in the circle like this. Whereby this is point E and this is point D. Then what this theorem is telling us is that if this angle here is K, this particular angle will also be K, because both of them are angles in alternate segments. This is a segment, this is another segment. Likewise, the angle here, if it is M, this particular angle here will also be M, because both of them are in alternate segments.
That's the much we can take today on the program. Join us next time for another educating session.